Okay, so why are these two colors in the title? What do you think? Because each line addresses a different audience here today. So the geospatial people who know everything about GIS formats, they need to learn something about long-term preservation, what this is all about. And the archivists, they need to learn what is geodata, what formats are there. So I will try to address both publics here to teach them and to show them what we think about and why we both would need to understand it. So one thing is, what are geodata formats? What is geodata? What formats can we expect when we come to the geodata producer? Just like Jakob said, we have different systems, different contexts, and so on, and also different softwares that are used over there. And for the geospatial specialists in the audience, we need to know how do we know if a format is good for long-term preservation? So we will do an exercise later in the lecture. So the first thing I need to say is digital information lasts forever or 5 years, whichever comes first. These are the words of the person that you saw on the image of the forecast of the home computer, Mr. Jeff Rothenberg from Rand Corporation. And in order to understand the gravity of problem, why is it important to have a specific format for long-term preservation, I can tell you on an example of lunar landing imagery. So what happened in the United States when NASA stored the imagery that they took when they landed on the moon? They kept it on the tapes, and after 20 years they said, oh, we can't even read these tapes anymore, let's repurpose them and let's tape over them. And then after a few years they noticed, uh-oh, we taped over the moon landing tapes. So they lost everything because they thought it's a format that we cannot read anymore. We can just throw it away. So in order to somehow protect it from this, they started documenting things. And they did the next thing. When they sent a rover to Mars in 1975, and they recorded some data on magnetic tapes, and they stored them as they should. But the problem was that in 1990s, they couldn't decode the formats they used. So what they had to do was go back, analyze, reverse engineer, and spend a huge resources to actually learn all about the information that they have stored. Because in that case, it was more expensive to send another rover to Mars than to reverse engineer all the data. So what we learned from this is it's very important to do archival thinking before we create a system and before we start working with the data. Just as Jenna said this morning, the archivists need to be engaged before the data is created, not on the end of the life cycle. So that's what we are talking about, life cycle management, not just archiving the data dump that we get in the end. The next slide I got from the Ariadne project, which is a project where they were analyzing how to archive archaeological data. And among them, there's also GIS data. And they said that they use so many different softwares for GIS and for spatial data because you need to know that also surveying measurements and photogrammetry softwares, which are very specific, they also create and manage geodata, but today we'll be speaking mostly about formats for GIS systems. But the problem is that the formats become outdated very fast. For instance, you cannot open a DBF file in the Access or in Excel in Microsoft Office 2016. You need to use a different tool, maybe an open source tool to do it. And shapefile is basically created out of shape and DBF files. So for those of you who know what shapefiles are, you know that it's difficult. We cannot actually read the database behind it if we don't have the tools. So we're getting close here. Then the hardware becomes obsolete. We know that the old data, the old systems were on heavy Unix machines that we cannot even turn on anymore, and nobody knows the operating system. And so the conclusion is that digital data is fragile because storage media deteriorates, then the software is overdue, is not up to date, formats go out of date, hardware goes out of date. So we need to find a way to actually document everything in a proper way, and this is what the specifications that we are creating on E-ARK and the long-term preservation format of choice are for. So, to the archiver audience now, what is geodata and how does it look like? When you go to the producer, what will you get? As Jacob already told you, you can get different systems with different formats. And just to give you a basic overview, to represent reality, the real world, we have two main ways of doing it. One is using the raster data, which are actually images. That's what you do when you scan a paper map. And then you have vector data, when you have actually coordinates with coordinate sets that define where the location is in a coordinate system. So when we choose which model we use, which data model we use, then we can choose what kind of modality there is. Is it a point? Is it a line? Is it an area? Where area can be used for defining a city, or if you have a large-scale map, then you use a point to define the location of the city. And you can use the same thing with raster, but there are some cases where raster is better to use. So if we take it, why we use raster data is maybe scanning old maps, getting satellite and aerial imagery, and then we have the calculated rasters, which actually cover large areas, like heat maps of density, or population density, or, I don't know, disease outbreaks, ecological disaster location measurements. So we can present, as they said in the beginning, everything was created someplace, in some location. So we can then analyze it through that. And of course, we can use it for terrain. So we use rasters mostly for the terrain and non-discrete GIS elements. And when we start to think about the formats, this is just some of them. You know TIFF, and you have 20 types of TIFF. There's a special type of TIFF, which is called GeoTIFF, which also has coordinates inside and coordinate system defined. Then you have JPEG 2000, some files that are of very special binary type. Then you have types for multi-spectral images. For instance, satellite images with multi-sensors, so that you can analyze very specific elements. And so, as we see, a lot of different format types. But how do we know which one is for the long-term preservation? This is something we'll talk about when we go to the criteria for long-term preservation. And we have the same situation in the vector formats. So we have a very known SRE shapefile, then we have the GML, which is a text file, and the GeoJSON, also a text file. Then if you want to publish things on Google Maps, you need to put it in Google KML. Then you have, anyone here uses Garmin? When you track your bicycle rides, they're tracked in GPS exchange format. Then you have a different software, map info and OpenStreet and so on and so on and so on. So a lot of different formats, which one can be used to archive it? First of all, I presented vectors as something that's used as a line, a point, or a polygon, but let's complicate things a little bit more. In GIS systems, these are systems about objects in space. So the purpose of the system is to give us a way to get information about this space. So if we have complex vector systems to give us information, for instance, this is a parcel fabric of a cadastre, where we have buildings, we have parcel boundaries, we have parcel area, and we have parcel points. So the parcel points is where the surveyor sets his instrument to know where the location is. And these things are fluid, and these things are in a system. And if you move one point, all the other things move. And this is called a topology. But how are we going to store topology with the shapefile? Not enough. Next thing, you have a complex utility networks which enable you to see if I close the water main here, who will go dry? If I shut down the power here, which users will have no electric power? And this is what this is used for. But if I only store the locations and I don't know the behavior of this network, then I lose the functionality that I want to use in the future. So it's also important to store this in a proper way. Then we have multimodal transportation networks. This sounds very complex, but to put it in perspective, if you want to get here from your country, you can go on Google and say, from my home to the location in Domus Medica. And it will calculate how much do you have to walk to your train station or to your taxi, or and then to get to the airport, and then to fly to Vienna, and then to take a train to Ljubljana and take a local bus here. So these are the multimodal networks that we use today, and that give us a possibility to calculate distances. For instance, who uses this? Rescue, first aid uses this to know where to put their rescue vehicles in order to access all the parts of the city in the shortest amount of time, and et cetera, et cetera. So there's a lot of ways to use geodata, and in order to reuse it in a proper way in the future, we need to also know how to store very complex systems. But to go back to the words of Mr. Radovan in the morning, start slow. That's why we are starting with simple vector data sets, and that's why we need some more input from you how to store it. So the academia, the solution providers, the producers of geodata, you need to tell us what do you need in the future from the system that you use. So currently, we use geographic database formats to store this complex vector data. One is Esri geodatabase, then you have Oracle Spatial, PostGIS. A very interesting format would be the OGC Geo package, which can enable multiple elements inside here, which actually based on SQLite and so on. So we see that we have a lot of formats for the complex vector data. So this is what you will find. When you find data in RDBMS systems, you know, things might be easy, simple, or very complex. So now I told you what formats you can expect with the producers. But what is long-term preservation? How do we preserve maps for the long term? Well, this is one way. Okay, so this is a map of irrigation channels in Mesopotamia. So it held up for 5,000 years at least. But there are some issues with this format. Okay, let's say, I mean, it will withstand nuclear war, no doubt about it. But it's kind of clumsy, and you cannot do a Google search on it. So we have developed, so the archival science has developed certain criteria to choose the long-term preservation format, and here we have the elements that I need to check. One thing in this is openness. How open is this format? Is it proprietary from a specific company, or is it standard, like an ISO standard or something like that? Then how widely is it adopted? Does everyone use it? Because even a very open format, if it's not used anywhere, then there are no tools for it, there's no practices, no comments, no support. Then how complex is it? Can we understand it in the future if we lack some documentation? Do we have self-documentation within it? Is it robust? So if one bit is corrupted on the medium, can we still use part of that data or not? So this is where we see, okay, we can compress things, but if we compress things and one byte is destroyed, we might lose everything. And also, are there dependencies? Do we need to use it with something else? Okay. So let's, to make an exercise out of it, let's check between the two formats, the GML and the shapefile for the vector data. So GML is actually a text file. It's based on XML structure. You can see everything inside. So you can read the coordinates, you can read the titles, the elements of the attributes, you can read the coordinate system. So here you see everything can be actually read and understood. So in the end, you could print this on paper and have it stored on paper if you want to, or you can take a solution of one of our sponsors, the Pickle company, that actually puts everything on film, and you can use it later on with just visual tools. The second thing is, this is what I opened with Notepad. Well, actually Notepad++. And then I tried to open shapefile with the same shapefile of the same data with Notepad++. It's not human readable. So it's a binary format that has certain elements inside, but I can't even recognize anything, nothing in a header. It's not readable. If I don't have very good documentation on this format, I don't know how to use it. Okay? So this is the difference. Is the format human readable or not? Is it self-descriptive or not? Then, if we go to first criteria, which is openness, there are some sub-criteria. Is this data a standard or not? So if we check the shapefile, it's a de facto standard, which actually means everyone uses it. So you have support in all major softwares for GIS for shapefile. But shapefile was created by a private company who actually says, here are the specifications, but there is no guarantee that in future years someone will buy them and say, okay, now we're closing the format. Not reliable. But GML is actually based on a standard. So it's an ISO standard that's very well documented, and we can be sure that it will stay this way forever. Then the next thing is there any restriction on format interpretation? Because you might have some restrictions by licensing. For instance, if you have a TIFF file, there used to be licensed tools. You could not have open source tools because it was a format that had licenses attending to it. But these two formats are both with no restriction. Then, is the reader freely available? Is there the source code for the reader freely available? We don't know. But in these two cases, if we can open it with QGIS, which is open source, which we know that we have a code for, then we can say, yes, it's freely available. But it's not the case for other formats. For instance, in JPEG 2000, which is a raster format, we know that there are some limitations on what tools can be used to actually access all the information inside. Maybe there has been some changes in the past years, but 5 years ago there was still an issue with it. Then the next criteria is adoption, how widely acceptable it is. Well, there are two types of adoption. One is worldwide usage with the users, and the second is usage as a archival format. So shapefile is very widely used over the world, and GML not so much. Why not? Because it's something they have to add specific elements into the software so that they can read it. But this is not really important for long-term preservation, because this is something that you need to be able to interpret, but the speed here is not of crucial importance. But is it usable as an archival format? Well, GML is getting more and more used as an archival format because of all the elements that I already told you about and the elements that we will see in the future. So next thing here is complexity. How complex is it for us to understand and read the format? Is it human readable? As we saw before, GML is human readable, shapefile is not. So we can open it with a text file and we can read it. Is it compressed or not? Both are uncompressed. And the point of compression is, as I mentioned before, we shouldn't compress data that we archive in the repository, because if one bit gets corrupted, the whole package might be corrupted. The next thing is variety of features. The more complex the format is, the harder it is to interpret it. But on the other hand, shapefile lacks some elements that GML has. So in the shapefile, we cannot store arcs. We cannot store topology. We cannot store additional metadata elements, which is something that we'll talk about in the next criteria. So the next criteria is self-documentation. If we open the shapefile, first we see nothing. Then we need some extra files with it. If we want to, we need to have an extra XML file. To all of those who are taking pictures, the presentations will be available on our webpage, and also the videos will also be available. So, but I'm glad you're interested. So, in the shapefile, if we want to embed georeferencing information, so in which coordinate system the data is in, we need to add a specific file to it. So it's another node of error, another possibility for mistakes. But GML actually supports to embed all this information within the GML file, because it's an XML file. So it's also an excellent format. The next thing is robustness. So how is it if we corrupt one bit? Do we have tools for corruption detections? For instance, since XML is built, GML is built on XML, we can use XML schema validators to check if the format is as it should be. We cannot, of course, check for completeness of data, but also shapefiles, since it has been around for a long time, we have validators, as I hope that Rebecca from United States will show us tomorrow. They use a validator for shapefiles because they accept anything they want, or anything they get. And then the format stability. But this is where shapefile is better, because as Jakob previously mentioned, GML actually gets new versions every couple of years. And shapefile has stayed the same for all this time. But on the other hand, GML now offers more information, more functionality than it did 20 years or 10 years ago. So is there backward compatibility? We have to search this out. We have to find out if this is true. And this is also, why did I put the question mark here? Because we don't know everything. That's why we need you. That's why we need to start talking, to start discussing about which formats can we use all over Europe, because as you saw in the Danish example, they actually went to analyze the formats themselves, the archivists. And of course, it would be much better if we put all our minds together and get a common agreement. And this is what the e-archiving building block is all about. So dependencies, in a shapefile, you need a specialized GIS reader, which you can get, but still you need a specialized GIS reader and know how to use it. But the GML you can open with a text file, so there's no dependencies. So in conclusion, GML is more open, human-readable, robust, self-documenting, but it is less adopted in the archives, and you cannot use it in GIS tools. In most tools, you need to know something else about it, add some plugins or so on. S3 shapefile is more widely adopted, supported in readers, but it's less open, proprietary ownership. We have it is less robust, it lacks self-description, and so on and so on. So what I would say is that GML is better for long-term preservation, and shapefile can be used for access and availability. So when we create a DIP, we convert it back to shapefile, or we have both formats respectively. So what's next? First of all, we need to analyze more formats for vectors, more formats for rasters. We also need to decide about which elements we should use inside the metadata, and there's so much more to do, and we cannot do it alone. So as Janet mentioned in the morning, we have a DILSYS board, which is a standardization body, and if there are also any other standardization bodies, we will need to connect and make a group and decide upon the best long-term preservation format for European Union or even wider. So this is what I would ask you to join us, to contact us, and those of you who said that you would like to be notified, you will get an email after the conference where we will send you a link where you can apply. Now, to give credit where credit is due, where do I get the resources for this? A very, very resourceful site is done by the American Library of Congress, where you can get on their webpage, geopreservation.org, you can get descriptions and archival commentaries for all GIS formats, almost all GIS formats. Then the E-ARK project, of course, and as I mentioned, the Ariadne project, and the evaluation of the file formats was done according to the presentation and the paper of the Caroline van Wyk from the National Library of Netherlands. So this is all from my part in this presentation, so if there's any questions.
Thank you, Gregor. Do we have questions, or do you think that any of these formats will survive 20 years? Let's bet. Yep.
Actually, you inspired the question that I am going to pop. There is some criticism on some GeoService OGC standards, GML, too complex, difficult to use, not connected to the IT guys. Let's do new things. OpenAPI, GeoJSON. What's going to happen to GML? All these efforts in all these application schemas, XML well documented and whatever. What's the risk here? Because, we can lose some things in the simplicity.
Well, if I look into the GML file and the format itself, I think we can put simple things in. The benefit of it is just like if you have a book with many stories, you can read just one story, you don't need to read them all. Here, you can use one part of the standard, not all of them. It is complex, but on the other side, we can use it in an easy way. So.
XML is bigger, more robust, more harder for Python. So maybe that's additional reason for leaving XML.
But this is take the right tool for the job. If our main issue is long-term preservation, we can wait for the longer parsing and stuff. But if we can't open it and understand it, then it's a problem.
Another question. The major point is user-friendly. As a user, information is like a national monument. When it is archived, when it is accepted as an archive information. Then, as a user, I can go into the town and I can see monument that is seen because it is standing there. On the other side, I'm also a user as an archaeologist that dig into the rubble and put out things that were deep under the ground. So both are users. If we specify only format, will we become archives, or will this information be in the future? Viewable by an ordinary people. So as a developer, I mean, I'm in the beginning of this life cycle, service life cycle. What should I put into specifications for development to make user job easier at the end? Is it only format that will be enough, or is it any other, I mean, requirements or I would say archive advice to put into specifications this and this and this? I mean, you know what I mean.
Yes. I will answer this question in great detail tomorrow morning, because I will talk about the specifications for archiving geodata, where the long-term preservation format of data is just one thing. The other things are technical documentations on logical structure of the database, queries that were used, examples, documentation, and so on and so on. But this was actually a very narrow, specific presentation answering one simple question: what is a long-term preservation format and how to use it?